There is a road bike hanging in a garage somewhere near you. Carbon frame, deep wheels. It cost more than some people's first car. Mechanically, there is nothing wrong with it. It has never been crashed, it shifts perfectly, and it is now worth a fraction of what it was because of one component the industry decided to change: the brakes. In less than 10 years, road cycling replaced a braking system that had been refined for over a century. Not gradually, not as an option alongside the old one, almost completely. And in doing so, it made every road frame, every fork, every wheel, and every hub built before that decision incompatible with almost everything built after it. Riders were told this was progress, safer, more powerful, more controlled, and in specific, measurable ways, that is true. But there is a question underneath all of it that very few people asked out loud while it was happening. Did cyclists actually need disc brakes, or did the bicycle industry need them? By the end of this, you will know exactly where the engineering advantage is real, where it quietly disappears, what the change cost you, and whether that bike in the garage was ever the problem. Start with what almost every rider believes, because it is the belief the entire transition was sold on. Disc brakes stop you faster. It is an easy thing to believe. You squeeze the lever and the bike responds with an urgency that a rim brake rarely gives you. That sensation is completely real, but the conclusion most riders draw from it is wrong, and understanding why is where this whole story begins. A bicycle brake does not stop a bicycle, it stops a wheel. What stops the bicycle is the grip between the tire and the road, and the limit of that grip has almost nothing to do with which brake you bolted on. There is a second limit, and on a bicycle it usually arrives first. Brake hard at the front and weight transfers forward. The rear wheel goes light, and at a certain point the whole machine begins to pivot around the front axle. That is the ceiling, not the brake. On dry tarmac, a well-adjusted rim brake with decent pads can already reach that ceiling. Squeeze hard enough and the front wheel locks, or the back of the bike comes up and the rider goes over the bars. Once a brake can do that, adding more braking power does not shorten the stop by a single meter. You have run out of road, not out of brake. This is why carefully controlled dry weather braking comparisons between good rim brakes and good disc brakes so often produce results that disappoint people expecting a revolution. The difference is small. Sometimes it simply is not there. So if raw stopping distance was never the real advantage, what was? The answer starts with water. A rim brake uses the wheel as its own brake surface, right where the tire meets the weather. Every drop of water thrown up from the road lands on the exact ring of aluminum or carbon that the pads need to grip. When you pull the lever in the rain, the first part of that pull does not break the bike. It clears the rim. Experienced riders learn to live with that delay so completely that they stop noticing it. They brake earlier. They feather the levers on wet descents to keep the braking surface dry. They have absorbed a limitation into their riding and stopped calling it a limitation. A disc rotor sits down at the hub, higher above the road, spinning through far less spray. Made of steel, gripped by pads that behave far more predictably when wet. That delay largely disappears. And it is here, in the rain, not on a dry test track, that independent testing consistently finds the gap that actually matters. Then there is heat, and heat is where this stops being a preference and becomes a genuine engineering problem. Braking converts speed into temperature. On a long descent, a rider is asking the brake to shed the energy of a heavy body and machine falling 1,000 vertical meters or more, and every bit of that energy has to go somewhere. With a rim brake, it goes into the rim, which is bonded to a tire, which contains pressurized air. The industry lived with that for decades because aluminum spreads heat well, and most riders never brake hard enough for long enough to find the edge. Tandem riders found it, loaded tourers found it. For everyone else, it stayed theoretical. And then carbon wheels arrived. Carbon composite does not move heat the way aluminum does. Braking energy concentrated in the resin holding the rim together, and above a certain temperature, that resin begins to soften. Manufacturers responded with specialized brake tracks, high-temperature resins, brand-specific pad compounds, and careful advice about descending technique tucked into the owner's manual. Think about what that actually was: an entire industry engineering around a problem it had created by putting the brake in the worst possible place on the bicycle. A disc rotor has no such conflict. It is a piece of steel hanging in open air, doing nothing except getting hot and cooling down again. It is not holding a tire. It is not holding the wheel together. Separating the braking surface from the tire is not a marketing idea. It is the strongest engineering argument in this entire story. There is one more advantage, and it is the one riders underestimate the most.
Hydraulic disc brakes need far less hand force. A cable brake pulls a steel wire through a housing, and friction eats a share of everything you give it. The longer the cable, the more complicated the routing, the dirtier the system, the more you lose. On an hour-long descent, that becomes a physical problem. Hands cramp, grip fades. Riders with smaller hands, riders carrying luggage, riders carrying more body weight, all run out of strength long before they run out of road. Hydraulics remove that. The system delivers almost everything you ask of it through one finger all the way to the bottom of the mountain. That is not power, that is control that refuses to degrade. So the case for disc brakes is real, and it is stronger than most of their critics admit. But if that were the whole story, the industry would simply have offered them as an option, the way it offers different gear ratios, and let riders choose. That is not what happened, and the reason has surprisingly little to do with braking. Take the pads off the rim, and something quietly enormous happens to the rest of the bicycle. For 100 years, the rim had two jobs. It held the tire, and it was the brake. That second job dictated everything else. The rim needed two parallel, machined flat walls a fixed distance apart. It needed to survive heat, it could not be too wide because a caliper had to reach around it, and the frame had to carry a brake that bridged directly over the tire, which set a hard limit on how much tire you could fit. Delete the brake track, and every one of those constraints disappears at once. Rims could get wider. Wider rims support a wider tire in a better shape, which improves grip, improves comfort, and at real riding pressures reduces rolling resistance rather than increasing it. Rim profiles could be shaped purely for airflow instead of being compromised around a flat pad surface. Frames could open up enormous tire clearance because nothing had to reach over the tire anymore. The caliper, one of the least aerodynamic objects on the front of a bicycle, moved out of the wind and down beside the hub. Almost everything riders now take for granted on a modern road bike depends on that single change. 32mm tires on a race bike, all-road geometry, tubeless systems designed around wide internal rim widths. The entire gravel category as it exists today simply could not have been built around a rim caliper. Disc brakes were never really a braking upgrade. They were a permission slip for a decade of frame and wheel design that could not otherwise have existed. Which brings us to the part the marketing was much quieter about: what it cost. Start with weight, because it is the easiest thing to measure and the least important thing on the list. A complete disc system adds rotors, calipers, hydraulic lines, heavier hubs, a much stiffer fork, and stronger wheel builds to handle braking force arriving at the hub instead of the rim. On a modern bike, that is a few hundred grams. On a climb, that is a rounding error next to the rider's breakfast. It matters far less than the internet insists. Complexity matters much more. A rim brake is visible. If it rubs, you can see why. If a pad is worn, you can see it. Almost any adjustment can be made at the roadside, with one hand and no tools. A disc brake is a sealed hydraulic system with alignment tolerances measured in fractions of a millimeter. A rotor that is very slightly bent will sing on every rotation. A caliper that shifts a hair out of line will drag. A pad touched by chain lube or degreaser may never be quiet again, and generally cannot be cleaned back to life. Bleeding the system needs a kit, a procedure, and a fluid specific to the manufacturer. Some use mineral oil, some use DOT fluid, and putting the wrong one into a system destroys its seals. None of this troubles a professional workshop. All of it moves the rider one step further from being able to look after their own bicycle. Then there is the part that emptied garages. This transition did not change one component. It changed the entire interface between the wheel and the frame. Quick-release skewers gave way to 12mm through axles because the old system was never designed for braking force arriving at the hub. Frames and forks adopted new caliper mounting standards, and hubs needed a rotor interface, of which there were two competing versions. The practical result is something every rider who has tried to move parts between bikes has run into. A rim brake wheel will not fit a disc bike. A disc wheel will not fit a rim brake bike. A rim brake frame cannot be converted. The most valuable component most cyclists own, their wheels, became untransferable in a single product generation. And the top of the market closed the door behind it. As flagship group sets were renewed, the rim brake versions were not renewed alongside them. If you wanted the best road components a manufacturer made, at some point you no longer had a choice about brakes at all. So was this a conspiracy? That accusation gets thrown around constantly, and it does not survive contact with the evidence. Disc brakes were not invented to sell road bikes. Mountain biking adopted them from the bottom up in the late 1990s because riders in mud and on long descents could feel the difference immediately and demanded it. Cyclocross followed for exactly the same reasons. By the time road cycling arrived at the argument, the technology had already been proven for years by riders who genuinely needed it. What is fair to say is this.
Once the road transition began, the industry had extraordinarily little reason to slow it down. A change that simultaneously makes every frame, fork, wheel, and hub in the world incompatible is not an ordinary product update. It is the most complete replacement cycle a mature industry can realistically hope for. You do not have to believe anyone planned that to notice that nobody was in any hurry to offer riders a way to opt out. And the sport's own hesitation tells you how contested it was at the time. Disc brakes entered professional road racing on a trial basis. The trial was suspended after a rider suffered a serious leg injury and publicly blamed a rotor. The cause of that injury was never established. The trial resumed anyway, and within 2 years the question was closed permanently. The debate did not end because it was settled. It ended because the product lines had already moved on, which leaves the only question that actually matters to you. Where does your money go, and who is this for? If you ride in genuinely wet weather, on real descents, or somewhere with grit on the roads all winter, disc brakes are not a preference. They are the correct engineering answer. And there is a second benefit people constantly forget. Your rims stop being a consumable. A rim brake slowly grinds away the wheel it is mounted to, and in a wet, dirty climate, that wear is real enough that rims eventually have to be replaced. Disc brakes move all of that wear onto a rotor and a set of pads, both of which cost a tiny fraction of a wheel. If you are a heavier rider, if you tour with luggage, if you ride a tandem, or if hand size or grip strength limits how hard you can pull a lever, hydraulic discs solve a real problem that no rim brake ever solved.
If you ride gravel, the decision has already been made for you, and it was made correctly. Wide tires, mud clearance, and a rim caliper cannot coexist. But if you ride dry roads, in flat or rolling country, on aluminum rims, and you already own a rim brake bike that fits you and works, nobody has given you a good reason to replace it. Your bike is not obsolete. Its resale value is. Those are two completely different problems, and only one of them affects how you ride. And there is one case where this transition has actively made things worse. At the bottom of the market, a cheap cable-operated disc brake on a heavy entry-level bike is frequently a downgrade. It is heavier, it is fussier to set up, it is harder to keep quiet, and it does not deliver the lever feel that made hydraulic discs worth having in the first place. Riders in that price bracket were sold the appearance of the upgrade without the engineering that justified it. So go back to the bike in the garage. Nothing about it stopped working because the industry changed its mind. On a dry road, it will brake as hard as the tires allow, which is exactly as hard as anything else on that road. What it lost was not capability, it lost compatibility. And in an industry that sells complete bicycles and complete wheel sets, compatibility has always been worth more than performance. Disc brakes are better. That is the honest answer, and the engineering supports it. Not because they stop you faster, but because they stop you the same way in every condition, on every descent, with a hand that does not tire, on a wheel that is finally free to be designed for what a wheel is actually for. What they were not was urgent. Riders were told they were buying safety.
What most of them were really buying was the next generation of frames and wheels, and the brakes were how the industry got them there. Knowing which of those two things you are paying for is the difference between an upgrade and a replacement, and that difference is worth more than any component on the bike.